Probability distribution is nothing but the system which gives the values of a random variable with the help of the probabilities. In terms of probability is called as probability distribution. The probability value of the random variables, when you add it, it results 1. The probability value of all the random variables which is less than or equal to 2 is 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the random variables and their probability distribution. So what is this random variables? Let's see it. A random variable is a real valued function whose domain will be the set of a sample space. So let us take an example of tossing two coins simultaneously. So the sample space of the experiment will be HH, HT, TH, TT. Let X denotes the random variable. So when I say let X denotes the random variable, a capital X is used to denote a random variable. So what is the condition that X is a random variable? I need to find out the value of X where the number of heads can give you the random variable. Now, here when I say X is the random variable, so I can take, so for the first outcome, number of heads is 2. For the second outcome, number of heads is 1. For the third outcome, number of heads is 1. And for the fourth outcome, the number of heads is 0. So this is what the random variable. So when I say X is the random variable which denotes number of heads in each outcome, so this is what the value we get. The value which we assign here will give you the random variable of the particular outcome, and we can write this in terms of probability, and that is called as the probability distribution of each outcomes in terms of a random variable. So for a certain set of a sample space, we can have many random variable. Now for the same experiment, let me take one more random variable, that is Y. What does Y denotes? Y denotes number of heads minus number of tails in each outcome. Now when I say the sample space HH, HT, TH and TT. So here what is the number of heads in the first outcome? 2. Number of tails? 0. So 2 minus 0 will be 2. Next in the second outcome, number of head is 1, number of tail is 1, 1 minus 1, 0. The same for the third one. Now number of head is 0, number of tail is 2. So 0 minus 2 is minus 2. So thus we can say the random variables that denotes the number of heads minus number of tails will give you the outcome or the values for the sample space like this. Hence, we can assign or we can say X and Y are two different random variable defined on the sample space of the experiment where we are tossing two coins simultaneously. Like this, we can have any number of different random variables applying the conditions for the given set of sample space. So these are called as random variables. And probability distribution is nothing but the system which gives the values of a random variable with the help of the probabilities. In terms of probability is called as probability distribution. Thus, generally we can define the probability distribution as if x1, x2, xn are the different random variables and their respective probability values is p1, p2, pn, then the probability distribution can be represented in terms of a table where first row contains the random variable x1, x2, xn and the second row contains P1, their respective probabilities P1, P2 and P3. And hence here generally there must be the non-zero probability, or we can say non-zero events. So that means the probability value of all the events here must be greater than 0, and when you take the sum of all the probability, the value must be equal to 1. So this is the condition for the probability distribution of all random variables. That is, the sum of probabilities of all the variables must be equal to 1. Now let us take a problem related to these distributions. Two cards are drawn successively with replacement from a well-shuffled deck of 52 cards. Find the probability distribution of the number of aces. So, we have 52 cards here. So, I have to take 2 cards out of 52 cards, and that must be aces only. What is the probability of getting an ace here? So, I can get 4 aces out of 52. So, this is the probability of getting ace out of 52 cards. Now, what is the probability or the random variable where both are not aces? So, that means both the cards, the first card which I have chosen is not an ace, and the second card which I have chosen is also not an ace. So, that is not an ace means it is exactly 48 by 52 into 48 by 52. So, when you cancel this, you will get the value as 144 divided by 169. Now, this is my first random variable. My second random variable, either I can get 0 aces out of 2 cards or 1 aces out of 2 cards, or 2 cards are also aces. Now, what is the probability of getting only 1 ace out of 2 cards? So, that it may be in this form. A first card may be an ace and the second card may be not an ace. Or I can say here, the first card chosen is not an ace, but the second card chosen may be ace. So, these are the options I can have when I take 2 cards. So, what is the probability value for an ace? We have 4 out of 52. And here it is 48 by 52. Next here 48 by 52, 4 out of 52. Again, when you solve this, the value is 24 by 169. Next one is, I can get 2 cards also ace. So, that is my third random variable, probability of the counting, that is 2 also or random variables. Both my first card is also ace and second card is also ace. So, the maximum I can get is 2 ace cards. So, therefore, it is 4 by 52 into 4 by 52. So, the value is 1 divided by 169. Now, writing this in terms of table. So, x. So, counting of x. So, no aces, 0. Only 1 ace, 2 aces. And writing the respective probability value of random variable. For 0, it is 144 divided by 169. For 1, it is 24 divided by 169, and for 2, it is 1 over 169. So, thus, these are the probability distribution of a pack of cards where I have taken 2 cards, out of them are 2 are aces. So, we can get neither aces, we can get only 1 ace, or we can get the 2 cards are also ace. So, these are the individual probabilities of the condition. Now, when you add it, as I said, in terms of probability distribution, the value of the random variables or the probability value of the random variables must be equal to 1. When you add it, 144 plus 24, it is 168. 168 plus 1 is 169. 169 by 169 is 1. Hence, the probability value of the random variables, when you add it, it results 1. Next, find the probability distribution of number of heads in 2 tosses of a coin. So, when I say the sample space will be H, 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 T, T, H, T, T. So, here I have the random variables. So, what is the probability distribution of number of heads? Number of heads may be 0 in one outcome, 1 in 2 outcomes and 2 in one outcome. So what is the probability value here? So 0 means here, so we have only one outcome where there is no heads out of 4 outcome. Hence the value of the probability is 1 by 4. Next, we have 2 outcome where it has only one head out of 4. So therefore the value of the probability is 2 divided by 4. Next, we have one outcome which contains 2 heads out of 4 outcomes. So therefore it is 1 by 4. So this will be the probability distribution of the random variables according to the number of heads in an experiment of tossing 2 coins. So therefore add this, you will get the value as 1. 1 by 4, 2 by 4, 1 by 4 is 1. Hence this is the distribution of probability according to respective random variables. Next, find the probability distribution of the number of tails in simultaneous tosses of 3 coins. When I say tossing 3 coins, the sample space is as follows. H, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, 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 T. Now what is the maximum number of tails we can get? 3. Minimum number of tails? 0. So therefore the random variable starts from 0, 1, 2, 3. Now here is our probability distribution. Now how many outcome contains 0 tails? Only 1. So that is HHS. There is no tails, and the number of tails in the first outcome is 0. So out of 8 outcomes, 1 outcome has 0 tails. How many outcome contains only 1 tail? So 1 tail, when I say these 3 outcomes contain only 1 tails. So that is 3 out of 8. How many outcomes contains only 2 tails? So these 3 outcomes. So 3 out of 8. How many outcome contains 3 tails? Only 1 out of 8 outcomes. So therefore the probability is 1 by 8. So this is the probability distribution for the given experiment. Now add the probability 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. The value is 8 by 8, which is equal to 1. Next, let x denotes the number of hours you study during a randomly selected school day. The probability that x can take the values of x can has the following form where k is some constant. So now here probability value is 0 if x is 0, kx if x is equal to 1 or x is equal to 2, k into 5 minus x if x is equal to 3 or x is equal to 4, 0 otherwise. Find k. First let us write the random variables which we can take is 0, 1, 2, 3, 4. Now respective probability values. If x is 0, the value is 0. If x is 1, it is kx. So 1 into k, k. If x is 2, it is k into 2, 2k. Now if x is 3, 5 minus 3 is 2, 2 into k, 2k. If x is 4, 5 minus 4 is 1, 1 into k, k. So this is the probability distribution here. Now I need to find the value of k. We know that the total sum of the probability distribution whose probability is equal to 1. Hence, I can write here k plus 2k plus 2k plus k. The first probability is 0 is equal to 1 because when you add all the probability in the probability distribution, then the value must be equal to 1. So when you add it, you will get the value as 6k is equal to 1. So therefore the value of k is 1 divided by 6. Next question. The random variable X has a probability distribution P of X of the following form where K is some number. Now if X is 0, it is K. If X is equal to 1, it is 2K. If X is equal to 2, it is 3K. 0 for any other values. Determine the value of K. Find P of X less than or equal to 2. First, let us write the probability distribution table. We have the values 0, 1 and 2. So, for X we have 0, 1 and 2. And the respective probability value is given, that is K, 2K, 3K. So, K, 2K, 3K. My first question is I need to find the value of K. So, when you add all the probability here, K plus 2K plus 3K, the value is 1. So, therefore, here we have 6K is equal to 1. This implies K is equal to 1 by 6. The next thing is I need to find the sum of all probability whose value is less than or equal to 2. When it is less than or equal to 2 means I need to take the probability value for 0 plus probability value for 1 plus probability value for 2. For X is equal to 0, it is K. For 1, it is 2K. For 2, it is 3K. So, we have 6K, which is 6 into 1 by 6. 6 cancels. So, the value is 1. Hence, the probability value of all the random variables which is less than or equal to 2 is 1. Next, a random variable has the following probability distribution. So, the random variable and respective probability values are given here. We need to determine for the probability value for all the random variable X greater than or equal to 2. Now, here for X greater than or equal to 2 means I need to take the probability of a random variable X is equal to 2 plus probability of a random variable X is equal to 3 plus probability value of a random variable X is equal to 4. So, what is the value we have here? 2K plus 2K plus K. So, this is 5K now. Now, to find the value of the probability, I need the value of K here. So, for that, I know the sum of all the probabilities here will be equal to 1. So, that is 0.1 plus K plus 2K plus 2K plus K is equal to 1. That is, we know that. Now, adding all this, we have here 0.1 plus 6K is equal to 1. Here we get 6K is equal to 0.9. Then when you divide it by 6, K is equal to 0.15. So, this is the value of K. Now, substitute here. Therefore, probability of all the random variables greater than or equal to 2 is 5 into K, which is equal to 5 into 0.15. which is equal to 0.75. So, this is the value of the given probability with respect to the random variable greater than or equal to 2. So, this is how we are going to find the probability values of respective random variables and write it in the probability distribution table. So, we will meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.